Hello everyone, I'm Ryan and he's Eugene. We are both engineers of GovTech Singapore and we are also product developers of Apex. Okay, welcome to our presentation about API monitoring with SRE. Okay. The key takeaways of this presentation is for you guys to discover the underlying technologies that power Singapore government APIs and have a peek into how we design our central API monitoring dashboards around the SRE principles. Our presentation will be broken down into these three stages. The first, I'll be sharing with you the context of the platforms that we have and how these platforms intersect in the API lifecycle. Following which, Eugene will take us into the dashboard deep dive, where you'll get to see how we actually do our dashboard based on SRE design principles, and also major events in Singapore that we undertake and how our dashboards help us. Following that, we also introduce our own self-engineered authentication for APIs and how dashboarding helps with that process. Finally, at the very end, the floor is open for any Q&A, so feel free to ask any questions if you have any. Okay. So with that, let's begin our presentation with our first platform, Apex, the one that we're working on. Okay, so what it is a full-fledged API management platform of the Singapore government tech stack that allows government agencies, businesses, and any developers to manage and share their APIs. So what's so special about Apex? Because for us, our gateways, we exist in two main zones, the internet and the government intranet. And what that has allowed us to do is to have a diverse range of different government agencies having the ability to host their APIs with us. They could be in the internet, they could be in their own intranet spaces. It doesn't really matter with us. We provide the support for them to coexist together. And with that, we do have actually usable examples in today's live production setting, where we have different agencies like CPF, IRAS, MOM, that has collaborated on singular APIs, regardless of where they are. And we have purposed it to such a way that developers can use them and create like meaningful APIs like text filing and all these different APIs that we hold as government. The other benefit that Apex provides is that we help all our tenants, any of our agencies, stay secure and relevant with all the best practices in API management. So if you onboard with us, that's great. We'll take care of all the heavy lifting for you, and you get to focus and enjoy your API innovations on your own time and pace. The next product that we'll be talking on more about is this thing called StackOps. And essentially what it is really just the Elastic Stack for the government. Okay? It's built and designed with the intention to support SRE and to push government into the SRE space. Okay? It has helped us a lot as Apex developers to reduce our operation overheads. Because what it is also a software as a service. We will run this Elastic Stack without having to worry about all the configuration efforts and all these settings to get this thing up and running 24/7. This is all taken care for us and we get to enjoy that privilege. The other benefit that we have is the accelerated mean to resolution. What this means exactly is because it's Elastic Stack, it has the capability for us to do all our monitoring right off the bat. We enjoy the privilege of just when an error happens, we have set up in such a way that we can recognize and quickly debug this without having to worry about tracing all the different pieces of our systems altogether. Most importantly, as part of this presentation, what StackOps has given us, the Apex folks, is the ability to monitor the 4 golden signals of SRE. And they are the latency, traffic, error, and saturation. All of this will be covered in the subsequent part of our presentation. Okay, so you've seen our two products, our two platforms. Now we'll see how they intersect with one another. What we have is this 3-layer approach when it comes to monitoring and observability. The very first layer is the observe stage of the API lifecycle. As active applications of our consumers consume published APIs in our platform, all these traffics and transactions are logged and piped, shipped into StackOps. We do take extra care to redact sensitive information. In fact, the whole body payload, we do not monitor and trace this. We allow our tenants to monitor that themselves. What we are monitoring for is the transaction as it is. The next layer is as users use our platforms, for example, our API managers, our API portals, and they perform different activities to either subscribe to APIs, recycle their API keys, create new API keys and whatnot. These transactions are also logged into StackOps. So if a feature has been published and may have been breaking in production, for example, we'll be very quick to be notified because all these are being tracked in our consolidated monitoring ecosystem. The last layer is our critical metrics for our infrastructure. Similar to the stage before that, If there's an infrastructure configuration that's breaking our system in production, we'll be very quick to observe this in our centralized monitoring system. Yeah, so with that, we hope that you build the context of what our platforms are and how they intersect. Moving on, we'll go into site reliability with Eugene.
Before I carry on, we would like to give special credits to our reference material, which we are heavily inspired by, which is the Site Reliability Workbook, Practical Ways to Implement SRE, which is published by O'Reilly, specifically the third release. And though we speak about monitoring carried out in Apex, which is an API gateway, all these principles will apply to any API backend as well. With that, we will deep dive into the SRE principles which guide our monitoring. Okay, first we go into SRE. These are 6 SRE principles, of which 7 is the 7th is monitoring. Basically, monitoring is used to measure SRE performance of systems as well as latency and speed of processes. As such, we can see that almost all of the principles of SRE depend on monitoring. So monitoring is actually a cornerstone of SRE. Okay, the first principle which we will deep dive into is interfaces. So the same data is actually displayed differently to different audience, depending on and in Apex we actually create dashboards which show that. For instance, in these 2 dashboards, the left side shows the end-to-end traffic latency health, whereas the right side is a more deep dive into the individual components which make up the end-to-end systems, which is used by the engineer which is responsible for troubleshooting. Okay, the next principle which we are going to is actually ownership and tooling, which is to use the same tooling regardless of function or job title. So basically, how we implemented this in the Apex is that we actually use the common monitoring tool in order to look at business metrics, API performance, application, as well as infra logging. And what this means is that actually our product managers, our DevOps, as well as our customers all use the same monitoring software. And this actually incentivizes Apex to improve our monitoring system, to realize so that everyone can benefit from it. And this also allows everyone to have the same tool to do troubleshooting together. The next principle which we're inspired by is speed. And basically what the workbook says is that data more than 4 to 5 minutes stale will significantly impact how quickly we can actually respond to an incident. So what we noticed was that API metrics going through the logging pipeline, which were implemented out of the vendor's Kubernetes manifest, were actually taking between a few minutes and a couple of hours to be processed and to reach StackOps. And so data was not fresh, and this affected our ability to actually carry out troubleshooting with our customers. So in evaluating our logging infrastructure, we actually optimized every single hop and re-architected the entire logging infrastructure to make sure that that logging was actually optimized and timely. And now we are pleased to announce that logging takes a couple of seconds to less than 3 minutes during peak hours. And the next principle which we are heavily influenced by, probably the most important, is in that of modeling. So critical user journeys are modeled to help for us to capture the experience, and from the workbook we would also have to be mindful of the architecture diagram of the system for the critical components, as well as the request flow, the data flow, and the dependencies of these components. And also in designing a dashboard, we have to implement the metrics in a very basically we have to be thoughtful in the metrics which would go on the dashboard, which will allow us to diagnose the issue faster. And this is how we design our critical metrics dashboard. And basically, they are actually systems which serve the traffic that affects the bottom line of Apex, which is essentially our API calls. And we will actually being extremely intentional and concise about what metrics to put in these dashboards, not to put too much, but not to put too little as well. So we mapped out the paths of the infrastructure as well as which supports this critical system, and that includes Kubernetes nodes, pods, database, as well as load balancers and for proxies, alongside the API business metrics. Okay, with that, we will now deep dive into how we prepare for major events which our platform support. So we would typically design a custom dashboard for the event that shows the business metrics, as well as other metrics which are important for the event, such as the API status codes as well as latency. Links to other dashboards which allow for deep troubleshooting are also embedded in the dashboard itself for quick troubleshooting. And typically, we would also engage in end-to-end load tests with the API consumer and publisher. And this would actually allow the backend server, the publisher, to ascertain the performance of the backend server, and for us to test the usefulness of our dashboards as well. And basically, the SRE principle used here is actually modeling user journeys, which is modeling the critical user journey, user experience. And these are the dashboards that we come out with, and these are basically the golden signals, the error rates, the latency, as well as the traffic. And this also shows the links in the dashboard, which would help engineers to quickly troubleshoot issues. Okay, next we will deep dive into dashboarding for authentication or APIs. So with that, we will give a little bit of introduction to what JWT authentication is. JWT authentication, which is the typical API authentication used in Apex, is essentially a client-based client assertion-based security mechanism for APIs, which allows us to incorporate authentication, authorization, data integrity, as well as non-repudiation. And it's loosely based on a JWT header, in which the API consumer would sign, and Apex would essentially verify the claims and signatures. So on the right, we can see what a typical JWT looks like. So with JWT authentication, the problem statement which we were faced with was that a good percentage of our troubleshooting tickets went to the investigating authentication and authorization tickets. And basically, the error codes of the at that time were all 401 and 403, and our ops team had to deep dive into logs to investigate every single incident or every single case which authentication wasn't working. So we created our uniquely defined error codes and customized the monitoring setup so that we could help the DevOps team to be able to analyze issues without having to deep dive into log files. And this is what our customized error codes actually look like. As we can see, most of the issues that customers will face were actually listed here as unique error codes, as well as we can see the bottom bar, security event will also log in error codes. And this is what our dashboarding looks like when customers were trying to, when they were migrating to our platform. When we used this dashboard, it was easy to work with our publishers and consumers to troubleshoot their authentication and authorization issues to pinpoint the errors quickly. And so this actually enabled users to diagnose issues and using a self-serve model. And of course, it was time savings for DevOps without being able to provide rectification recommendations without needing to read the logs. Our DevOps team was also able to diagnose if there were potential security threats to API gateway by just looking for error codes which were reserved for security errors, as we seen before this. So the SRE principle that is of interest here is actually to engineer toy of system, which essentially states that the optimal strategy for handling toy is to eliminate it at source, working with product development teams to develop operationally friendly software that's not only less toysome, but also more scalable, secure, and resilient. With that, we have actually come to the end of our presentation. Thanks for staying till so far. And with that, now the floor is open for Q&A.